Hi everybody, my name is Mike Hoskins. I'm CTO of Pervasive Software, and I'd like to welcome you to SuperComputing 08. For those of you who don't know, this is the biggest supercomputing event of the year. This is the 20th anniversary, and we're having it right here in Austin, Texas. Austin, Texas is our hometown for Pervasive Software, and so a little bit unusually for us, we decided to host a booth. So we have a 10 by 20 booth showing off our most advanced research in software here at SuperComputing 08. I've got four things I'd like to share with you just briefly today. First is the main point of the event for us, and that is to introduce DataRush to the public. What is DataRush? DataRush is a platform that we've developed to allow you, the developers, to create massively parallel, data-intensive applications on commodity SMP hardware. So that's a mouthful. Let me parse it out for you. People have to develop parallel applications. It's top of mind topic for everybody. And how do you do that? It's a very hard problem. And so we're offering DataRush as a SDK, as a programmer's framework, a high-level abstraction layer so that you can develop massively parallel software without being a superstar in parallel programming. DataRush as a framework hides all the complexities of parallelism, so you don't have to worry about memory management or threading or deadlocks. You're composing massively parallel data-intensive applications at a higher level of abstraction, and then you're handing that work off to the DataRush SDK and the DataRush engine. We happen to use Java as our core development platform, so we run on the JVM. It has a great threading model. It scales fabulously for SMP multi-core hardware, so we get tremendous throughput in terms of parallelism. It's also a very friendly developer environment for you as well. We happen to use data flow principles. Data flow is a very elegant architecture for scaling for large data volumes. So DataRush gives you a weapon to tackle what we call data-intensive high-performance computing. So high-performance computing has traditionally lived kind of in the, let me load it all in memory, let me do a matrix, let me do some math with a Fortran algorithm. And that's not going to scale anymore. We now need to cope with exploding data volumes. So we call that data-intensive high-performance computing. It scales on multiple dimensions. You need to cope with very large data volumes. DataRush can scale for any amount of data volumes. You don't need a lot of memory. You have to scale for hardware hyperparallelism. We use auto-scaling, and so as you add more cores and you add more threads, your program automatically scales wider. We scale for cognitive load, for programmer productivity. As I said before, you don't have to be a parallel programming expert. And finally, we scale for economics because we can run on these amazingly inexpensive and powerful SMP multi-core workstations. In fact, we have one right here at the show floor, and so we're showing a personal supercomputer. It has in it 32 64-bit cores. It has 64 gigabytes of RAM. It has 12 terabytes of high-speed RAID 0 hard disk. And the entire workstation costs maybe $15,000. So you have an opportunity to run a massively parallel data application on an incredibly inexpensive box if you have the right software like DataRush. And oh, by the way, that box is going to be 50% less expensive every year for the foreseeable future because of the power of commodity hardware development. So we feel very good about DataRush and its ability to exploit SMP multi-core commodity parallelism. As an example of an application over on this side of the booth, we're showing a very advanced data mining algorithm, K-means clustering, and so DataRush would be good for data mining. To try and pick a popular data set and a popular problem, we went with the Netflix Prize competition data set. It's 100 million reviews, 480,000 users, 17,000 movies, and we're doing traditional single-dimensional K-means clustering with K equals 30, so creating 30 clusters and finding the aggregates. But we're also doing some very advanced co-clustering, multi-dimensional clustering across the Netflix data set. We're finding linear scaling on our multi-core boxes. In fact, we're processing the entire Netflix data set in a matter of a few dozens of seconds, something that nobody else is doing, especially on this scale, on this kind of box. So it gives you an idea of the power of DataRush. And finally, we're showing, the last thing is a visual data mining application. The power of parallelism is immense, but not everybody can be a parallel programming superstar. And so we're trying to do, in some of our advanced research, a high-end graphical user interface so you could do parallel data mining without being a superstar parallel programmer. And so we're going to glue the power of DataRush into this very beautiful high-end data mining software. Right now we're showing an SOM application here on the data mining screen, and we're going to offer that so you can do parallel data mining without parallel programming. So there you have a snapshot. I hope that's interesting to you. If you're in Austin, I hope you get a chance to visit us, and if you don't, come visit us at www.pervasiveDataRush.com. Thank you very much.